Hi, my name is Kostas. I'm the Manager of Operations at AMS-IX, and I will be presenting the operational overview today. So, as every year, so let's proceed. Let's start by reviewing the agenda. Sorry, something is, yes, the agenda. So you know what to expect. We'll start with the platform upgrade, we'll review the platform upgrade, which basically is numbers and trends, incidents and maintenances, review and overview, and then we will also check the comparison between this year's and previous year's tickets. Then we will review what we've done during this year. We will also talk about some of the projects that we are working on at the moment, and then we will go further in the looking ahead section and go through what we will work in during this year until the next MoreAP. So let's get started. In this graph, we can see the tickets from last year, the last 12 months until end of April, since the last MoreAP event, compared to the year before. As we can see, more or less it's the same. The trend is almost the same as the previous year. We have some spikes here and there, but basically they're pretty much stabilized. As we can see, there are some spikes, and these were more or less, but not exclusively, due to increased connections, upgrades, more provisioning actions. We had a few scripts that were implemented in order for us to keep our platform clean and inform the customers if there is some unwanted traffic or unallowed traffic, but also some stale BGP sessions that are being still active in the platform. We also have some more new scripts that have been implemented, which basically were for us to check configuration, audit configuration, check also if there is some remnants or any kind of issue that we should be looking at. That's also proactively. The last part was that we basically get a lot of TECL auto-reply messages, and they were mostly, thank God, sent to knock@amsix.net and not to everyone in TECL, but there are some occasional emails sent to all TECL. As you can imagine, not only this annoys some of the subscribers, but at the same time, it adds a lot of workload for us, so we need to review all the tickets, weed through them, see what are actually need to be updated or looked at, and also inform the customer not to send it. So, as the previous time in MoreAP, once again, a plea to all, please stop sending auto-reply messages to knock, even if it's only to knock. So let's go to moving forward. Let's see what we have announced. We have announced 139 tickets this year, 57% more than last year, which was 89. We had a total of 50 incidents, 22 of which were service affecting. 18 of those were in the NL region, 3 of them in Mumbai and 1 in Manama. We also had 28 of them that were non-service affecting, and they were pretty much spread throughout the whole, all the exchanges. On top of this, we had 89 announced maintenances. They were touching upon other services, so most of the services, and they were touching upon multiple exchanges also, so they were announced for each exchange. 19 of these were platform related. This was basically related to customer migrations, customer swaps, PXE-related issues, firmware upgrades, reboots, but also line card replacements, and of course, the configuration changes and the likings. We had another 15 maintenances that were regarding the route servers, and which were mostly related to configuration pipeline changes, but also they were related to the BGP large communities migration support. We had also a lot of other maintenances announced, and they were basically related to all the other services we have. For example, servers, storage, WAN routers, firewalls, portal, my AMS-IX website, everything. Let's go and check these two graphs, which are basically a lot easier to compare. We can see that we had last year's and this year's incidents. We had 50 instead of 30, and they were more, but they were mostly more because of the non-service affecting incidents, and they were 28 instead of 14. There were also 23 instead of 16. Yes, 16 service-affecting ones, but we will review them later. We also had maintenances, and they were a lot more, 50% more than last year, 89 instead of 59 that we announced last year. Basically, their increase was, again, mostly due to other maintenances. If we can see at the numbers, they are 55 instead of 30. We had announced basically triple the route server maintenances, and they were mostly due to what we said, the BGP large communities and the pipeline configuration. And we had a lot of other maintenances also announced. So let's drill down now and see the service-affecting incidents and what happened. As we mentioned on the previous slide, we had 22 of them in NL. In general, for NL, we had 13 interface flaps due to PXC or in general due to swaps. We had one of them which was related to service degradation, and 4 of them, related to service outage. For AMS-IX Mumbai, we said we had 3 service degradation related ones, and for AMS-IX, we had 1 service outage. So let's go to what we had for remote exchanges first. AMS-IX Mumbai, we basically had, as we said, 3 service degradation ones. The first 2 were kind of identical. The backbone links between the 2 sites flapped for around a minute, and this basically caused the sites to be isolated between each other for a very short time. The third one was partially, it was also flapping, but there was mostly because of a very extensive outage that happened on the sites, on the whole region there. There were multiple fiber cuts, and this affected the backbone links for 72 minutes. For the AMS-IX one, we had a service outage, and this was due to the switch that we experienced an unexpected reload of the switch. This was 8 minutes until the switch came back and started serving traffic again. So for NL, we had the 1 service degradation. This was partial connectivity with issues with stub-tel 239. This was around 1 hour. It was basically due to a backbone link that was misbehaving, causing some IP connectivity flows, issues between specific source and destination IPs. Not everyone was affected as far as we can tell, but it was identified and isolated and fixed. Then we had service outage ones. The first one was because the line card of the stub-tel 339 rebooted unexpectedly. It took 4 minutes for it to come back, so the customers were experienced an outage of 4 minutes. The other one was again a line card reboot, but in a different stub this time, stub IX9241, and this took 8 minutes to recover. And the other one, the last one, in this slide, we have 232 line card, again unexpectedly rebooted. It failed actually, it needed manual action to be recovered, and it took 47 minutes for it to go back to service. The last one is not accidentally kind of separated, it's on purpose. I think that this is what you basically, everyone probably experienced and are aware of. This was the loop incident of 6th of April. It took 27 minutes until everything came back to normal, and well, we know how we felt. So I will invite my colleague Steven and AMS-IX Dinosaur. He has some slides that he wants to share with you.
Yes. All right. Thank you. Is my mic on? Yes. Wait. Oh, that was that one. Yes. That was the loop. Okay. So yeah, a little bit about loop mechanics. Part of this is a repeat, so you might have a bit of a déjà vu of the last time we had something like this, at which I made this beautiful drawing of an instance where you get a loop on your platform. So first I'll talk a little bit about anatomy of a loop. So in our case, the instability, what a lot of people often think is that the instability comes because the looping traffic causes high CPU and switches falling over. That was the case, I think, in the early 2000s. If a loop happened, your platform was host. This is something that the switches actually can handle very well. They just keep forwarding traffic. But the real problem lies in that your BOM traffic, so that's broadcast, unknown unicast, multicast traffic, is being replayed by the loop. And that causes the MAC addresses, causes MAC station movements, because the source MAC address of BOM traffic gets learned behind the loop. So traffic to those addresses is actually routed back to the loop. And back then I made this beautiful drawing as well, where you see, in this case, 3 routers that are happily exchanging traffic, and there is a loop at the bottom left. As long as they all do nicely unicast, nothing goes wrong, until the first one starts sending something like a broadcast or on a unicast. In this case, per illustration, it's an ARP query. It gets routed back to the loop, and you can see this little CC, which is the MAC address, now gets learned behind the loop. So any answer that comes from, for example, B, is going to be routed not to C, but it's going to be routed to the loop, where it also gets replayed. So now the MAC address of B is learned behind the loop, which causes all the traffic to B also to be rerouted. And then A starts to do something similar, and slowly but surely all your unicast traffic ends up in the loop, where it gets black holed, and the only thing escaping is your BOM traffic. So that's a nice analogy. Your layer 2 loop is basically unicast black hole. One of the things that causes it, like I said, is broadcast or multicast traffic. In principle, we shouldn't see too much unknown unicast. We shouldn't see too much broadcast or multicast, because the recommendation that we say is, set your ARP cache or your neighbor cache timeouts to 4 hours, because there's not that much MAC IP changes happening anyway. So why does a loop, or this particular loop, take effect so very quickly? Well, there's a dirty little secret, and there's a dirty little typo. There's a dirty little AMS-IX secret, which is called arpkeepalive. Background of that is that in 2009, when we migrated from VSRP to VPLS and MPLS, we noticed that root server peerings can actually cause unidirectional traffic between peers. Because normally, if you have peers with a bilateral peering, bilateral BGP session, they will send keep alive and everything. So there is bidirectional traffic. But if you go through a root server, it can happen that one is sending traffic to the other one, but there's nothing coming back. If that happens, we noticed that especially in the MLX platform, there were CAM timeouts happening. Not MAC table timeouts. So if you actually logged in on the switch and you say, well, where's this MAC address? It would happily say, no, that's behind that port. There's no problem. We know where it is. But the CAM on the line cards doesn't know this anymore, because they get flushed around every 30 seconds. So as far as the line card is concerned, as far as the packet processor is concerned, this is now unknown unicast, and that causes high CPU on the line cards, which is very mysterious to us. CAM timeouts on the MLX is not configurable, so this poses a problem for us. How can we keep the CAM entries hot? Well, the answer to that is what we created back then, arpkeepalive, which should be called camkeepalive. It's too late to change that. And the trick is to actually solicit an unknown unicast packet from all known peers. So we know which IP addresses are assigned on the platform. We pretty much also know to which MAC address they are assigned. So what we do is you send a unicast ARP request to each of those known peers, and you craft it as such. You say, who has target IP? So you ask basically the station for its own IP address, and you say so send a reply to a bogus IP with a bogus MAC. And that bogus MAC is an unknown MAC address on the platform, so the unicast reply is flooded on the platform. So the advantage of that is that the peer's source MAC address is now learned on all the switches, and that's how we keep the CAM hot. Thing is, this runs every 25 seconds. So when you do create a loop, within 25 seconds, all the stations on the platform will have been sending unknown unicast. And that basically means that arpkeepalive is accelerating the impact of any kind of layer 2 loop you have. And it's kind of, we sort of dug our own grave here. Solutions, we've looked into that. Can we kill arpkeepalive? Well, not yet. As long as we have AMS-IXs in the platform, that's really not an option. So it's good that when we finally start implementing the Junipers, we will try to flush out the AMS-IXs first. Then, before we go further, we kill arpkeepalive. And that would be a happy funeral, I think. The other thing is to eliminate layer 2 loops. Then you don't need any of this nonsense. And for that, we would really like to migrate to EVPN. And again, that's not something we can do just in one day. So in the meantime, what we have looked into is to improve the testing procedures to reduce the chances of loops, because this one really only happened because we were doing snake tests on a switch. And it was a really unfortunate coincidence of events. And so if we think that by improving the instructions or improving the procedures on that, we can catch that in the future. We're also working on better monitoring and alerting to actually do not just loop detection, but also immediately know where it is looping. So there's some very bright ideas going around for that. And that's it. So if you have any questions, I'll put on my dinosaur suit, and that's it. Anyone? No? Okay, then I'll hand it back over to you. Thank you.
Yes, one, yeah, okay. So yes, as Steven said, of course, we reviewed all the procedures, all the processes that we are implementing, and we actually sent an update to TechL with the root cause analysis and what happened. If anyone has any questions, obviously you can find me later on during coffee break, or you can ask now, or you can even reach out with an email. Let's proceed with the rest of the presentation. So let's review what we've done so far since last MoreAPI. Of course, the Core Move project was one of the very big ones, highlight of 2021. This was hands down the most complicated, extensive, potentially impactful project that we have performed. It's also required a ridiculous amount of preparation, coordination, cooperation, planning, and of course configuration changes. As you can see in the LinkedIn update here, we have actually pushed around 3.2 million configuration changes to make this happen. We've not only moved the P router, of course, as this is basic for the core move. This is the only part that is actually related to the platform, but we also have a lot of services. We have servers, storage, firewalls, management network, WAN routers, transit connections that need to be moved, and this, as Tim said, happened in a later stage, but before the end of the year. As far as SLXs, another big project that we did was management network. This was, for us, it was very important to give the needed attention to the management network. As we all know, management networks sometimes do not get any attention at all until something happens. So we said our services rely on it, so we need to invest in it and make it as good as we can be, we can do it. We have worked a lot in performing a large amount of fixes, optimizations, cleanup, changes, and of course, at some point, we also upgraded the newest possible version that we have. We can upgrade on our pluribus switches. As far as the SLX are concerned, we had a series of upgrades throughout the platform to address all the issues we had the last couple of years. We are also working on testing the new version, which is the 18.1M. And this is also it's supposed to fix a couple of issues that we have, and this is more than welcome. As a spin-off due to that, we have also had to migrate to a new configuration template because one of the upgrades and one of the software upgrades actually caused a change on how things are implemented in the ACLs, and we had to change our way of implementing the ACLs throughout the platform. And of course, this also led to another round of maintenance for configuration changes. What else? As Tim said, we've worked on the RFP and the POCs. I will not dive into details on that, but you can imagine this is a very big project, changing the whole platform, switches and everything. For the route servers, we have implemented large communities, and we have also optimized the configuration pipeline and also implemented and migrated to the new looking glass. For the remote sites, we have completed the stub-to-edge conversion migration on the Hong Kong site. This was done fully remotely. We were not able to send any engineer due to the COVID. Big thanks to HSC team, our partners that helped, and they were very, very responsive and flawless execution. At AMS-IX, we have launched the reseller functionality that was very much needed and requested. And as IX as a service implementations go, we have basically launched 4 new sites, 4 new XPs with multiple sites. Calcutta and Hyderabad, Singapore and Egypt have 1. We are also working for more, of course, as Ruben, team, everyone said. What else? We are still working. We're implementing even more changes we implemented a lot of changes internally for tooling. This helps also not only our Kwanzaa colleagues, but ourselves, in order for us to be able to troubleshoot and perform operations quicker and everything. This is largely due to the Ops Tools project, which is a specific tool that will allow us to implement a lot of more scripts and everything easier. And as I said before, we have also implemented a lot of scripts and checks for inconsistencies, configuration audit, and everything. This is not only for the ISO need, but also for us to know what's happening proactively and as soon as it happens. And once again, we passed successfully ISO and Telecom Agency audit. What's happening now? We're working on another optimization, the AS1201 routers decoupling. This is basically to decouple our customer BGP sessions from our WAN routers. They are one and the same at this point. And once we actually migrate the BGP sessions, we can optimize configuration and even possibly redesign our layer 3 topology. Optimization of scripts, tools, monitoring, configuration, everything is ongoing, and we are reviewing a lot of things daily. More IX service deployments, and we have also working on implementing for the IX service project implementation, zero-touch provisioning, so we can very quickly, as Tim said, be able to provision and set up a new XP in a very short notice. And also, of course, we're testing the new SLX version that I mentioned, the M release, but we are also working on testing the J release, which is for the small pizza box switches that we are using for the IX service implementations. What else? Route servers. We're actively working on upgrading the OS of the route servers and upgrading to 168. This is mostly because we want to have every route server in the same version and not have differentiations between the remote platforms and NL. But we will be working on upgrading to higher bird version later on. Management network reconciliation optimization. There are a couple of steps that we need to still make in order for us to make the management network optimized as well as we can. There are some things that we need to make in order for us to basically fix the reachability quirks that are there and also improve a lot of security. And on our BSS and SS platforms, we are optimizing services, launching new services, ordering, provisioning, everything. And while doing that, we are also reviewing, as I said, all the steps, the ordering and the provisioning, and how everything works in the background, so we can optimize not only the ordering phase, but also the configuration phase. And of course, we are eager to participate in the 2Stick project. If you don't know what it is, please go and visit 2stick.nl. It's very interesting. Looking forward, what are our plans for the future? As Tim said, we are going to take part in the friendly divorce and of AMS-IX and NIKEF. This is, of course, a big project. IX service, more implementations, proof of concepts will be happening for the IX service next-gen switches. This is not only because this is basically because we would like to see how to scale things up in larger switches than only pizza boxes, and we will be looking into some other possibilities that we have in mind. Route service, we are working on upgrading to BERT version 2. We have heard, obviously, in RIPE that there is a BERT version 3 released, but this is heavily worked at, and it's in active. It's work in progress, yes. So we will not be looking forward to upgrade to that yet. And then we are also working on routing lab implementation. This is basically a way for us to be able to research a lot of functionality, new functionality, more features, and potential services to see if we can roll them out or how they should work and optimize them before we actually go to production. What else? Management network. As we all know, at some point, every hardware comes to an end. So our management network switches are closing to their end of support, end of sale. So we basically need to think about how to proceed. There are a couple of possibilities, of course. One is to replace the hardware and just continue with the overlay OS. We have pluribus and we can upgrade to a newer version. There are also other possibilities. We can basically upgrade to another OS that, with the hardware changes, will be probably or possibly giving us more features. But there is also the case where we basically migrate to a different open, not vendor-specific, not proprietary solution with specific. I lost my words a bit. So we can see if we can proceed with different protocols, different topologies, which are not going to be vendor locked. So we can be able to buy any kind of switch, and that will work, and it will be plug and play and mix and match configuration. So this is ongoing. We are already starting researching that, and we will see how it goes. Implementation of IMS-DSIM. This is very important for us. It will help a lot if in order for us to be able to know a lot of things in terms of all the information we have and be able to have all the equipment properly monitored in a database. DCI proof of concepts. We're working on that. We are. As you probably know, our current DCI vendor is not supporting the current version of the DCI that we have anymore. So it's becoming a bit more pressing as we proceed to find the next DCI vendor and what kind of hardware we will be deploying. So this is becoming some project that we will take on. Also, homegrown PXEs. I will not get into that as Tim explained it in detail. We are working on that, but once this is ready and this is handed over from our partner Turtle to us, of course there will be a need of configuration changes, reviewing, testing, and then putting it into production. And last but not least, we are always working on adding more tools for our Kwanzaa QNOC colleagues and training, of course, in order for them to make troubleshooting operations easier. And that's it. Any questions, suggestions?
Well, I've got one. I see Niels in the audience, so of course we're very eager to know if for the route service we're also going to experiment with OpenBGPD at some point?
Yes, this is one of the new.
Is it?
Yes,
so it's in the planning, right?
Of course it is.
Oh, it is. Okay, thank you. Any other ones?
It's already being tested.
All right, thank you.